All right, on this first page of the review, we're going to be practicing graphene quadratics and what that entails. So if you take a peek at this form that's given to us, it's being given in vertex form of the parabola. And so right when we look at this, we're able to identify the critical point of the vertex right here and right here. Remember that in this, if it has an x plus 2, it actually means that the vertex is going to start out with a negative 2. And then the 4 at the end is just a 4. You might be thinking for a second, wait, don't we switch both signs? We just did this circle formula that went x minus h squared plus y minus v squared. And you noticed that both of these switched signs. It's because both of them are inside of parentheses, and so both have the sign switch just like this negative 2. But see how in the vertex form that plus 4, that whole vertical shift is just right there at the end? So this plus 4 does not have a sign change. So just to reiterate, inside the parentheses, x plus 2 becomes negative 2. X minus a number becomes the positive number. Y minus a number becomes positive number because those are both in parentheses. But in vertex form of a parabola, this plus 4 at the end just stays a plus 4. So, okay, I've got my vertex of negative 2, 4. I'm going to go put that dot right here on the graph. And that's my starting point. So negative 2, up 1, 2, 3, 4. So that would be counting by ones here. So 1, 2, 3, 4, 5, 6, 7. Go ahead and label your axes. 7, 7, negative 7, negative 7. And this is your x and this is your y. Label and scale. Don't forget to label and scale. Okay, so that's my starting point, my vertex. Now I look at this stretch and orientation from the front, this negative 4. Because it's a negative 4, it means that this is oriented down, or an upside down parabola. Because it's a stretch of 4, it means it's going to go 4 times the usual speed. So a parabola, I'm going to go ahead and do this really lightly. I'm going to use a light green. A parabola normally goes out 1, down 1, and out 2, 2 squared is down 4. So the normal parabola would look like that. But this one is going at a faster rate, 4 times the normal stretch of a parabola. This one is going right 1, down 1, 2, 3, 4, 4 times the normal stretch. So it's normally out 1, down 1. We're going to make it 4 times that, out 1, down 4. And there's my parabola. Notice how much skinnier or steeper it is because it's going down 4 times as fast as the normal parabola. Next, they ask us for a domain and range. So just as a quick reminder that the domain of any parabola goes forever left from negative infinity to forever right to infinity. And then my range definitely has an upper limit in this parabola because it's an upside down. The range stops right there at that 4. Do you see how it doesn't go past a 4? But it goes forever down. So we're going to say that the range goes from negative infinity up to a 4 inclusive, and it stops right there at the 4. But since it goes forever down, we say that negative infinity. Okay, pause the video here and go try the next one on your own and see how far you can get or where you get stopped. All right, let's see how you did on that vertex. So here, this time, we see this, and so that vertex critical point is going to be a positive 4 because we remember to switch the sign when it's in parentheses. So right 4 and down 6. There's my critical point, my vertex. Now, by the way, go ahead and label and scale your graph, just like we did on the last one. Okay, starting at that critical point, this graph, instead of going the normal stretch, and by the way, it's positive 1/3, so my orientation is an upward parabola, unlike the other one that was a negative orientation. So positive 1/3 means instead of going the normal out 1, up 1, it's going to go up 1/3 of that speed. So out 1 is only going to go up 1/3 of 1. So it's literally going to be like a little tiny Out 1, up, bloop, like barely going up. Out 2 would normally go up 4. We're going to go up a third of the normal 4. So 1, 2, 3 and a third. Sorry, that's too much. 1 and a third is the 4/3. So up 1 and a third. You're noticing it's going to be going up very slow. Out 3 is normally up 9. So out 3 would normally go way up, but this is going to go up a third of the 9, or up only 1, 2, 3. So we see a slow growing, wide parabola that has a stretch of 1/3. Very slow growing, a wider graph. And we recall that a fraction is a wider graph, and that a whole number 4 is a narrower graph. What's my domain of part B? We recall that the domain of any parabola is all real numbers, or negative infinity to infinity. And the range in this case has a minimum and then goes forever up. So we're going to say that it goes from -6 to infinity, and the -6 is inclusive. We include that -6. What this is called, you guys, is the features of a function. And you in Math 1 did the features of functions for linear and exponential functions. And this year we're supposed to have a feel for quadratics, for the features of the functions. Okay, looking next, we're being given the graph, and now we need to write the function. So right across the top, let's write the formula for a parabola. There's some stretch A, x minus the horizontal shift of your vertex, plus k, the vertical shift of your vertex. And so right away we can see that we were given a vertex here and here. Actually, let me use a different color for that one. So we're able to just straight up plug that in. I'm going to put the answer down here. So it would be y equals x minus a -3 squared plus the k of 5. So are you okay that right here was the h and right here was the k of your vertex? H, k. So we plugged those straight in right here. But getting the a, the stretch factor, the thing in front of this, can take us, there's a couple ways to do it, but can take us another second. First of all, if the normal stretch goes out 1, down 1, I see that this is already going down faster than the usual. It's out 1, down 2, out 1, down 2. So the first thing I'm noticing is that it's an upside down parabola. The orientation is downwards, and so there's going to be a negative in front of this. So let's go ahead and just put in that negative to start. Now, to find the exact value here, I'm looking at the picture and I'm guessing that it looks like it's about down 2. My guess is that it's a -2. And I can look at the actual points and calculate it, but let's do the actual formula. Let's make sure we know for sure that it is a 2. So here I go plugging in to make sure. I'm using the original form, y equals a, x minus h squared plus k. And I'm plugging in this x and this y. So 3, the x is -4, the h is negative, there's a minus there, and then the h is a -3, and then it's plus 5. So I just plugged in all these things. Let me highlight so you can see where they came from. I got this -3 from right there. I got this 5 from right there. Then I got this -4, and I got this 3. Those all got plugged in as the x and the y and the h and the k. So now let's solve. We're trying to solve backwards for this letter A. So this becomes negative 4 plus 3. So this becomes negative 1 squared, which is just 1A. So I minus the 5 from both sides, and I get 1A equals negative 2. And I'm like, hey, wait a second. If A equals negative 2, check it out. That's exactly what I had for A, just based on looking at the picture and guessing. So this over here is a way to plug in and definitely know what it is instead of just trying to guess or look at the points and speculate. So plugging straight into the formula to solve backwards for that A would be the preferred method to make sure you get it right. All right, pause the video and go try this second one and see how you do on this one. Okay, let's see how you did. So the vertex, again, is given to us right away. Here's my H. Here's my K. So I can just go straight up, plug those in. I'm going to put my answer down here. I'm going to go x minus 2. There's my H. Don't forget the squared. And then plus K of 0. Do you want to write the plus 0 or just leave it completely off because you don't need it? Now let's go speculate about this A, and then we'll do the real deal plugging it in. Notice that the orientation is upward this time. Because it's upward, it's going to be a positive A value there in front. Now I'm noticing that I start at the point negative 1, 5, and I go down 5, 1, 2, 3, 4, 5, and over 1, 2, 3 to get over there. So I think that down 5 over 3, like, I don't know, is that going to be my answer? Is that just any point on the line? I'm not quite sure. Since I'm not sure, I need to go and plug into the equation and see for sure. So here I go using this color. So we're going to go plug in to solve backwards for the A. So my Y is a 5. Do you see me where I'm getting that right here? From the X comma Y. A is what I'm solving backwards for. My X is given right here. So I'm going to write negative 1 minus. My H is right here, that blue 2, squared. And then my K is just 0. I don't even need that. So 5 equals negative 3 squared. Do you see how that happened? Plus 0 can be left off. So 5 equals 3 times 3 is 9. And A equals 5/9. So starting at 5, going down 1, 2, 3, 4, 5, and over 1, 2, 3. But when we actually look at this, we notice that it comes out to 5/9. So let me go back in and highlight where I got these things. Here's our H. Here's our Y. Here's our K. And here's where we got the X. And then let me highlight this in the same color right there. Solving backwards for that A.